G'day there, you're watching the Aussie BIM Guru, and today I'm going to show you how to set up a quick little script in Dynamo that lets you sweep sheets and views off of sheets. So a lot of the time we need to clear up sheets when we're working on large scale projects because we might be rearranging views on them, and we don't just want to delete the sheets and the views together, and it can be quite a hassle to do this either way. So typically if you delete a sheet while it's collapsed in a browser, it just deletes the sheet and the viewport, so this isn't ideal. But alternatively, if your browser's expanded, which is really common when you're working in a team project, because usually people don't clean up and collapse their browsers, it will unfortunately delete nothing. It won't just delete not only the viewports, it will refuse to delete if you shift select them together. So we need to find a way to solve this using scripting. So we're going to sweep them off instead and keep our sheets using Dynamo. We're going to trigger a user interface in order to let the user pick their sheets rather than having to shift select and do it manually. We're also going to then sweep off the viewports and the schedule instances and keep the sheets. So we're going to be using the delete node from Archilab, probably the best delete node I've found so far. It's very thorough. And also just trigger a user message and get the viewports and schedule instances using the rhythm package. It's really important to note that the schedules that we're getting off the sheets are called schedule instances, not schedules. There are some nodes that get schedules on sheets, but they get the actual schedule itself. So if you delete that schedule, the schedule itself is gone too, and we don't want to do that. As well as this, we're going to use data shapes at the end to create a basic user interface for the user. So I haven't used data shapes for a while, so I thought it was good to include it in a tutorial again. So version 2.0.3 is ideal, because that's what I'm using, but I think 2.1 will probably work as well, but anything in the version 1.x may not work the same way. So without further ado, let's get started. So I'm just going to jump into the Autodesk Basic Sample project, and I'm just going to jump straight into Dynamo. So eventually we're going to get our sheets using a user interface, but to begin with, just to keep things simple, I'm just going to get them using a categories and an elements of category node, just so I can get all my sheets for testing. I find this is a really common technique I use when I'm going to use a user interface, but I don't want to trigger it every single time that I run my script, because I'm just testing, so I'm going to keep running it over and over and over again. So I don't want to pick those options every time. So we're just going to get the elements instead in a more direct way. So we're going to get all elements of category. And I suggest you do this as well if you're following along, because this means you can keep running your script and seeing the data flow as well. We should get a list of our sheets. So in this case, I have 6 sheets. Okay, so what we're going to do is grab the get viewports and views node from Rhythm. And from those sheets, we're just going to run that. And this node is great. It essentially gives you the viewports, the views, and the schedules. So the view is actually the view in Revit itself. It's not the viewport placed on the sheet. So we don't want to delete the view. We just want to delete the viewport, because this will basically essentially remove the view from the sheet, but keep the view in the project. Okay, so we're going to get the name of our schedules. And the reason we're doing this is because we need to filter out our revision schedules, because what this actually does is it goes and finds the revision schedule inside title blocks as well, and we don't want to delete that, because what it actually does is it gets inside the title block instance in Revit, and it actually successfully deletes the revision schedule, which is quite amusing. And then you won't see the revision schedule until you reload the family. So it's quite risky, because it might even be like an element corruption technically, because it knows it's meant to have a revision schedule in the family definition, but in the project it's been removed. So very interesting behavior there. So we're going to use a string contains node, because we're going to be getting rid of any revision schedules. Sorry, just use the standard revision string contains. Okay, and I'll just run this so you can see what the names are. But see, they're all called like revision schedule with triangle brackets around them, and there's only really a couple of actual schedules we want to get rid of. So we're going to use a code block, and we're just going to search for that triangle and revision schedule triangle. And on the second line, we will say we don't want to ignore case, so false, because we're matching that word exactly. And we should get a list of Booleans telling us whether it's true or false. Note that each of these is a sublist that correlates to the sheet itself that the schedule's coming from. So we're keeping that order intact for now. And the reason we want to do that is because we're going to pass a filter by Boolean mask over that list. So we're just going to filter those schedules by whether their name contains revision schedule. And we'll get a list of revision schedules and non-revision schedules, and any sheet that only had revision schedules will become a sublist that is empty. So it's important to note that. So what we want to do then is go back and get our viewports and our schedules and join them in a list. So we're going to use list join. String and list have a lot of very common overlaps in naming, because working with strings and working with lists is a very similar exercise. So we'll take the out list from our list of schedule instances, and we'll take all our viewports. And from this list, we'll also flatten them just into one big list. So we'll get a list of a whole bunch of little sub-lists of viewports and schedules and empty lists. And then once we flatten it, note that all those empty lists go. So when you flatten a list, it removes the empty data as well. So that's great. So pretty much we have a whole bunch of elements and instances that we can run a delete node over. So we're just going to get the Archilab element delete node. There's a few delete nodes across multiple packages in Dynamo, but I find the Archilab one works best from my experience. It's very thorough. Cool. And this will essentially remove all of those instances. So if I just run this once now, just to show you what happens, so I'll save, run, and bang, gone. But our schedules and our views are still in the project, so that's really important. I've seen some workflows of people using this and they actually delete the schedules without realizing it. There's a node, I think, in Clockwork that looks like it should get the job done, called sheet schedules. But it's important to note that it gets the schedule, not the schedule instance on the sheet. So it actually goes and deletes the source schedule, so don't use this one. It's a good node for what it is, but dangerous. Okay, so what we'll do now is generate a basic user message. So I'll just undo that and I'll just keep working with my script. So what I'll do for now is, I'll probably note first, when you delete using the Archilab delete node, I found that if the element doesn't get deleted, it gives you a false, and if it does, it gives you a true. So we want to count how many trues and falses we have. So what we can do to do that is just run a Boolean mask over the list upon itself. And if I rerun this, we'll get an in list that's filtered all the trues into an in list and all the falses into an out list. So we can count these two lists essentially. So we have 0 false and 22 true. So this is a way we can generate a count for a message to tell the user how many things we deleted. Okay, so, but it's quite tricky to test with a node like delete, because once it's deleted, like that's the run, it's done. So what we might do instead is just freeze this node and generate two dummy numbers. So we'll generate 22, actually I'll generate a list with 22 items in it. That's probably better. So we'll generate a list from 1 through to 21, so a range. And that's to simulate the number of things that were successfully deleted. And then I'll just get an empty list to simulate the number of things that were unable to be deleted. So I'll get an empty list. So now let's put together a user message. So we're going to use a big code block to do this. I've been using code blocks a lot more in my scripting than I used to. I find them really handy in condensing a whole bunch of design script into one block. So we're going to set a few elements, but the first thing we'll do is, actually I'll go get the rhythm user message so you can see what we're doing. So I'm just going to look for simple user message. Okay, so what we end up here with is basically a node that has a caption and a message. So if I just call this title and message, and I feed these in, essentially what this does is it just gives you a little Windows dialog to tell a user something happened. So if you're running this out of, say, Dynamo Player, this can be a good way to sort of get the user to understand when the script is finished and what it did, whilst giving them a really familiar and comfortable Windows dialog box, so they feel comfortable the script has worked. And you can use numbers and things to build messages, which is what we're going to do, to tell the user how many things succeeded, how many failed, and how many sheets it worked upon. That way, if a really buggy things happened, it'll be pretty obvious to the user. So we'll just call this sheets swept for the title. And we're going to create a few variables. So I'll create one called count1, and I'm going to call on the DS core, or the Dynamo script core language. And I'm just going to get list as my sort of sub portion of it, and I'm going to count. And we're going to count a variable called sheets. So we're going to count the number of sheets first. We're going to create a couple more variables, and we'll call those count2 and count3. And we're going to count two different variables. So we're going to count sheets. We're going to count, we'll count success, and we'll count fail. Okay, so essentially this is going to be the number of things that worked, the number of things that didn't, and the number of sheets. But now we need to build a message. So I'm going to make a new line, and I'm going to call this count2, which is the number of things that, oh sorry, not count2, count count 3. Oh no, count 2, correct. So count 2 plus, and we'll create a standard string called elements swept off, and we'll put a space, and I'll add the number of sheets because we want to say X amount of elements swept off Y number of sheets, Z failed, plus sheets. And you could obviously build a filter so that you don't even build a warning message into your script. I'll just put a bracket there. And then I'll just go plus, and we'll add the fail count. Count 3 plus failed. So let's try that. Let's try feeding in this list here for success, this list for fail, and we'll count the number of sheets back here. That's all right, I'll just feed that forward. What I might do is just move this up so we're sort of keeping our wires out of the way. Okay, so let's just see what message we get out of that. And you can see we got 21 elements swept off 6 sheets, 0 failed. So this is the message we'll feed through to Rhythm. So we'll get our caption and our message. And there you go, that's our little dialogue to the user. So that's a really handy little method I find for adding just a little bit of friendly user interface. We're going to go and put a front-end user face on this as well, but this is essentially the back-end user face. So we're going to say the number of successful elements, the number of failed elements, and we'll just delete those 2 test lists. So let's do a proper test with our back-end user face functioning. So we're going to unfreeze our delete node, and I'm just going to reopen the script just to refresh everything. And we'll run. Oh, just move this over. Interesting, the run started. I might just reopen the script again. I think Dynamo might have got hung up on something there. Or is there? Oh, there's a little dialogue in the way. Cool, so you can see our user interface has come up, it's worked, and our sheets get cleaned up. Pretty cool, right? So nice and easy. So what we're going to do now is just focus on our front-end collection method. So I'm going to freeze from my delete node again. And I'll just undo that deletion there. So what we need to do now is collect all of our sheets using data shapes. So this part's pretty easy. If you've seen any of my data shapes tutorials before, you'll be pretty familiar with how this part of the script works. But for those that haven't used data shapes before, this might be a good way to sort of come to terms with how data shapes functions. So I'm going to go ++ and search for the multiple input form ++. And essentially this is where my sheets will come from, out of my user inputs. So this is going to be my UI window that triggers everything to happen. What we need first is actually a button or a list view. So I'll look up UI list view, and this is going to give us a list of sheets the user can pick from in a tick box list. So we're going to build this button first. So this button needs a few things. It needs some keys and some values. So keys are what will show in the interface, and values are what will be pushed through for the respective keys that the user selects. So we're going to set a few variables. I'm just going to first go and set true and false because we do want to sort our items, and we'll also not show the ID. But what we need to do now is actually generate a few things. So we're going to get a title for our UI, and I might actually go and collect a few other things briefly as well. So what we'll do first actually is collect all our sheets. So we'll go back to over here where we got all our sheets and create a copy of this. And because we're building the final portion of our script, I might actually go and get the category by name. I find this is a little bit more stable between different versions of Dynamo. We'll look for the category of sheets. Because sometimes when you change versions, new categories are introduced to Dynamo. And what happens is these get offset by the number of new categories. So I prefer to do this so that it's always pointing to sheets no matter what. Okay, so we could feed through our keys and our values, but the problem is that we don't have a logical name for these. This isn't really a friendly way for our keys to read in a user interface. What we're going to do is build a formula out of the name and the number of those sheets instead. So we're just going to get sheet name and sheet number. And we might actually embed this as a code block function just to clean up our script a little bit. So what I'll do is connect my sheet name and my sheet number, and I don't know if these work with node to code, but if you right click with those selected and go node to code, Oh, cool, it does. So that actually converts this into a code block for us. And essentially we're just checking our sheets. So what we can do is just pass this and change our variable name for T1 to sheets, just to make it a more logical variable for the user. And we'll just call this name, and we'll call this number, because we're going to put these together in a little formula. Great. So we have our name and our number, but what we're going to do is just say that we want to put a string together called name plus semicolon space plus number. And then if we feed this in and run this whole node, it will basically give us a sort of a logical keys and values. We'll actually do number first, actually. That looks a bit strange with the name first. Great, and now we have a logical set of keys that the user will understand when they read them. We could also probably tidy this up even more and actually just put the title of our UI into the same code block, and also the true and the false in here as well, so that it's all just contained in one place. So what I might do is just move this here. You could even put like the collection method for sheets into the code block as well, if you want it to be really clean. So we'll say select sheets, and we'll say that our keys, actually we do need to feed through our variable for sheets too. So we'll just recur the variable sheets across. So our values, our keys, and also true and false. There you go. And you can see that's a pretty neat little way to build a button. What we need to do now with that button is make it into a list, because data shapes always expects the inputs to come in as lists. So we'll say that's our inputs, and we'll just get a few fields for our actual main user interface as well. So the first thing I'll do is actually get a file path, and we'll just put a little logo in here. I'm just going to path to this little logo that I've built for my script, under logo optional. Okay, but otherwise we're just going to make a list of things. So this is the title for our UI. So we'll say select sheets to sweep, and we'll make our run button clean them up, just to give it a bit of personality, and we'll make a cancel button. And then we'll just make the size of our UI as well, 1200 by 800, and we'll just feed all these variables in. So the title, the button text, the cancel button text, max height, and width. Cool. And then we need a Boolean to actually run the whole thing. So we'll set this to true. And that's pretty much it. So once we run this, we should essentially get a list of sheets out of here, but it'll be a list of lists. So we do need to get the item at index 0, because that'll be the only input coming out of here. I'll show you the data flow when we run this properly. Okay. And then all we need to do is just shift select these here and reconnect our script. So essentially this is our script at this point, all put together. I'll just keep this frozen for now, just to show you how data shapes works. So if I save and run, interesting, our button, there we go, our button needed to refresh. But that's essentially what we get. So we can pick 1, 2, 3, 4, clean them up, and you'll see that we get those through as a list, and then we extract those at their index to get all of our sheets that we're going to analyze. And from there, it just continues the same way as it would before through the script. So I'll just do one quick demo of the script, and let's run it out of Dynamo Player. So we'll go Manage, Dynamo Player, and just navigate to the folder that your script is contained within once it boots up. Dynamo Player is still a little bit slow sometimes, I find, but it's a better way for users to deploy their script safely. Cool. So I'll just go to my demo sheet sweep folder, and I'll just run my demo script. So I'll just press run, and because we have a full user interface, that we don't have to worry about the user having to edit the inputs of Dynamo Player itself, so we can just press play. I find the best scripts in Dynamo are the ones where you can just press play and the user doesn't have to visit the inputs window, and data shapes is a great way to avoid having to go to the UI window. So we'll just clean, let's just do select all. Clean them all up, there's a little logo, clean them up, there's our little message, and done. Our sheets are clean. So a really quick and straightforward workflow, I think, and a handy way of showing off data shapes as well, and packaging a script. So thanks for watching today. Hopefully that helped. Feel free to leave any comments or queries down below, or if you've got any suggested topics, let me know as well. I make videos 2 to 3 times a week and plan to do so for a long time. If you're not already following and subscribing, feel free to do so, and hopefully I'll see you in the next video. Thanks. Take care.